So again, our discrete probability distribution is the table or graph or the formula that gives the probability of each value for our random variable. So now requirements to have a probability distribution are that all the probabilities have to be greater than or equal to 0, no negative probabilities, and if you sum up all the probabilities for all the sample points, you'll get 1, which is 100%. So here's a distribution here. We want to determine if it's a discrete probability distribution. Well, the first condition is satisfied. All the probabilities are greater than 0. So probability of x is greater than or equal to 0. That one checks out. Secondly, do they sum up to 1? So 0.15 plus 0.2 plus 0.5 plus 0.25. So that's going to be 75, 85, 95. This is actually 1.1. Okay, not equal to 1. So no, this is not a discrete probability distribution. How about number 3 here? X is going to be the number of customers served at Starbucks inside a 5-minute period. So here's possible values, 0 to 11, and then the probability of each one of those values occurring. So this 0.09 is saying probability that 8 customers are served in 5 minutes is 9%. Is this a discrete probability distribution? So 1, probabilities greater than 0, greater than or equal to 0. That one checks out. 2, if you sum up all these probabilities here, so sum up all the probabilities in that row, and if you do, you will get 1.00 or 100%. So this is indeed a discrete probability distribution. So that one's a yes. And then they want to know what is the probability that x equals 8. So probability of 8 right here, 0.09. So probability 8 customers come through is 9%. What about probability x is less than or equal 4? So less than or equal 4 would be 0, 1, 2, 3, or 4. So this is saying probability x equals 0, 1, 2, 3, or 4. And it really means 0, or 1, or 2, or 3, or 4. And that or, that's an addition rule. So we just add up the probabilities here. So 0.01 plus 0.03 plus 0.05 plus 0.07 and plus 0.12. So what is that? 4 and 5, 9, 7, 16, 26, 28, 0.28. So 28% chance that the number of customers served is at most 4. Probability x is between 5 and 9, so that's strictly between, because they're strict inequalities. So this would be x equals 6, 7, 8, 6 or 7 or 8. Those are or probabilities again. We add up 2, 1, 1, 4, 0, 9. So what is that? 35, 44? So 44% chance that strictly between 5 and 9 customers are served. Probability that x is greater than 2. So greater than 2 would be 3 all the way up to 11. So x equals 3, 4, ... up to 11. And we could add up all those probabilities, but we know the total is 1. So we could just add the probabilities for 0, 1, and 2 and then subtract that. So shortcut here, we could do 1 minus the opposite probability, the complement, x less than or equal to, which is going to be 1 minus 0.010305. 0.01 plus 0.03 plus 0.05. So that's 1 plus 0.09, so 0.91. So 91% chance that more than 2 people would be served inside this 5-minute period, at least from the data that we have. So you're just adding up all the probabilities of the sample points or the outcomes that fit the described condition.